Um, Hello, I'm Huan. I will introduce the REST pipeline of our method. Um, Before my discussion, Jiaqi introduced how to transfer the rating data into the session data, and then use the session data to train a transformer for rec model to get some recommendations. As for me, as for my part, I implement the tag model. So here I will introduce how to get the data, the output from the transformer for recommendation model, and how to do some data process for the output dataset, and also how to train our tag model and get some result. Here, I firstly store the model parameters when the transformer for rec model overfitting. You can see the code. I just use some training session and put the training session data into the model and get some output from the model. You can see the tensor vector shows the scores for all the items for the input training session. As for so this is the training dataset. If I want to get the non-training dataset, I will input some non-training dataset to the model and get some output, get all the output from the model. And so here I get the output training and non-training data and store it. Because our attack model is a classification model, so it is supervised model. In that case, I need to do some data process for our training non-training data. Here, I label the training data as 1, label the non-training data as 0. So you can show the code. I get the training output, non-training output from the transformer for recommendation model, and also label the training and non-training in the code. So after done the data processing, I can combine the training and non-training data and use together to train our attack model. Here I just use the general classification model as attack model. Our task is to learn from the difference between training and non-training distribution, the features, and then can do well, and then we can use our attack model to predict any unseen data. The left picture shows how I use our data to train our classification model, attack model. And the right picture shows our model generalized well from the dataset I've provided and achieved the high accuracy. So I've done all the pipeline of our method, and now I move to the experiment, the result, and evaluation. Here, let's discuss the experiment setting. Here, I choose the dataset you choose, and the right table, the right picture shows the statistics of our you choose e-commerce dataset, and it has it lasts over 3 months and has over 50,000 items and has over 6 million sessions, over 26 million interactions. The average sequence length is 3.8. And I choose our environment is the paper space because it's easily to install the remoted cloud container, and also it can and the container get well with the NVIDIA GPU, so I can use the GPU to speed up. And also I can use the NVIDIA marine libraries like the NVTabular libraries or huge CTR libraries for the large-scale data processing. That's the reason why we choose the paper space. It's easy to space. It's easy to speed up the data processing for the large-scale data. And I select two baseline model. The first one is the biased MIA. That is the first algorithm to implement MIA against the recommendation system. And this paper identifies users through the difference between the user historic behaviors and the recommendations provided by the target model. And the second baseline model is the DLMIA that improved the first model by the deep-Bayesian learning. This paper designed a decentralized encoder and a weight estimator to simultaneously mitigate training data and estimation biases. And let's talk about the results. You can see the left picture is the visualization of the output of the transformer for RAG results by the TSNE, and the red point refer to the training data, and the blue point represents the non-training data. You can see the picture shows the distribution between the training and non-training data is totally different. So that's why our method can work. And the right table shows the attack performance of the sequential recommendation model. And our method achieves highest accuracy performance than other two baseline because our model utilizes the distribution difference between training and non-training dataset. As for the discussion and takeaways, in concluding, our proposed method introduces a novel and effective approach to membership inference attacks in sequential recommenders by leveraging the distinct output distribution differences caused by overfitting. And for the next step, I'd like to explore how to initiate MI attack on the same sequences because for the same inner training and non-training data, their distribution must be close to each other. So how to classify the same inner training and non-training sequential is a tough and interesting problem. Any questions? Thank you.